Hello guys, today we are going to learn about thermal expansion. So what can you say about thermal expansion? To me, I say thermal expansion is the increase in size that can be length, either area or volume of a substance when heated. You understand? So let's consider a rod of length L1. So L1 is the initial length of the rod, but when it's heated, after heating, that's when the length changes into L2 and it experiences a value of extension, which we represent it as E. That's what you see there, and L2. Going on, a linear expansivity is equal to alpha. Also, let delta theta be equal to change in temperature, where alpha is equal to L2 minus L1 all on L1 delta theta. But L2 minus L1 is equal to E. That's the extension, where alpha is equal to E on L1 delta theta. Applying change of subject to the equation that we have, we end up getting E is equal to alpha L1 delta theta. That's equation 1. Remember to always note the equation. We'll be using it for our question. Let's move on. So to recall, we know that alpha is equal to L2 minus L1 all on L1 delta theta, multiplying through by the base, that's L1 delta theta. We get alpha L1 delta theta equals L2 minus L1. So L2 is equal to L1 plus alpha L1 delta theta. So let's mark it as equation 2. I say note these equations, we'll be using it for solving our problems. So yes. Let's consider a square having, we know that square has area. Let's consider the first area to be A1 and the second area to be A2. So area 1 is equal to L1 times B1. Area 2 is equal to L2 times B2. So the coefficient of area expansivity is not alpha, but now beta, which is equal to, you have to know this, note this, never forget, beta is always equal to 2 times the alpha. That's the coefficient of linear expansivity. Take note of that. So from our normal routine, you know that beta is equal to A2 minus A1, as you do for the earlier ones. That's L2 minus L1 on L1 delta theta. So this one, beta is equal to A2 minus A1 all on A1 delta theta. where E can be E2 minus E1, multiplying through by the base, which is A1 delta theta. So we will be getting beta A1 delta theta is equal to E. Earlier on, we know that is extension. It's also an extension. So the extension is equal to beta A1 delta theta. That's equation 3. Take note of that. Or A2 minus A1 is equal to beta A1 delta theta. So A2 is equal to A1 plus beta A1 delta theta, because we are sending the A1 to the other side of the equation to become plus. So we know that factorizing A1 out, A2 is equal to A1 bracket 1 plus beta delta theta, equation 4. Anomalous expansion of water. It is the increase in volume of water when cooled from 4 degrees Celsius to 0 degrees Celsius. Also contract when heated from 0 degrees Celsius to 4 degrees Celsius. So let's consider the volume expansion of a material or anything. Let's consider a cube, or let's take a cuboid. So it has a length, breadth, width. So the first volume V1 is equal to B1 times L1 times W1, vice versa. V2 is the same. And we know that since we are in cubic, we have to get another value for the expansivity. And this time around it's gamma. But gamma is equal to 3 times the alpha. That's the linear expansivity. Through our normal routine, we know that gamma is equal to V2 minus V1, all on V1 delta theta. Multiplying through gamma V1 delta theta is equal to V2 minus V1. V2 is equal to V1 plus gamma V1 delta theta, where V2, factorizing out, V2 is equal to V1 1 plus gamma theta. So a question: calculate the expansivity of 1 meter of a copper pipe when heated from 5 degrees Celsius to 6 degrees Celsius if the linear expansivity of the copper is 0.00017 per Kelvin, given that L1 is equal to 5 meters. So delta theta, that is a change in temperature. It moved from 5 to 60. So the bigger one minus the smaller one, which is giving us 55 degrees Celsius. And the linear expansivity was given to be 0.00017 per Kelvin. That's it. From equation 1, we know that E is equal to alpha L1 change in theta. So you have to know these equations. That's it, take note of it. So now we are using equation 1, substituting the values we were given. Substitute alpha, you substitute L1 and delta theta into the equation. It maps that E is equal to 0.0017 times 15 times 55. Calculating, or E is equal to 0.014025. E is equal to 1.4025 times 10 raised to the power meters. You have to bring the meters. because in physics we need the units. So try your hands on this. An iron rod of length 5 meters and at the temperature of 60 degrees Celsius is heated to 70 degrees. Calculate the new length. Any problem, just send a question to me in my comment section.